Welcome. Today we are looking at electrolysis at a comprehensive level. This is a key topic in your chemistry exams for SS3. Pay close attention. Let us begin. First, let me review what electrolysis is. Electrolysis is the decomposition of an electrolyte by the passage of an electric current. An electrolyte is a substance that conducts electricity when dissolved in water or melted. The electrolyte contains ions that can move freely. When an electric current is passed through the electrolyte, the ions move to the electrodes. Positive ions move to the cathode. Negative ions move to the anode. At the electrodes, chemical reactions occur. Ions gain or lose electrons. This results in the formation of new substances. Electrolysis is used in many industrial processes. It is used to extract metals, purify metals, and electroplate objects. Understanding electrolysis is essential for understanding electrochemistry. Now let me explain the electrolysis of molten salts. When an ionic compound is melted, the ions are free to move. Electrolysis of molten salts produces the metal and the nonmetal. For example, molten sodium chloride produces sodium metal and chlorine gas. At the cathode, sodium ions gain electrons to become sodium atoms. The reaction is Na plus E equals Na. At the anode, chloride ions lose electrons to become chlorine atoms. Two chlorine atoms combine to form a chlorine molecule. The reaction is 2Cl, 2E equals Cl2. The overall reaction is 2NaCl equals 2Na plus Cl2. This is the industrial method for producing sodium and chlorine. Electrolysis of molten aluminium oxide produces aluminium metal and oxygen gas. Aluminium is extracted from bauxite by electrolysis. The aluminium oxide is dissolved in molten cryolite. The mixture is electrolyzed. Aluminium is produced at the cathode. Oxygen is produced at the anode. The carbon anodes are consumed. They react with oxygen to form carbon dioxide. This is the Hall-Héroult process. Now let me explain the electrolysis of aqueous solutions. When an ionic compound is dissolved in water, the solution contains ions from the compound and ions from water. Water contains H+ and OH ions. At the cathode, the cation with the higher reduction potential is discharged. The reduction potential determines which ion is reduced. If the cation is less reactive than hydrogen, it is discharged. If the cation is more reactive than hydrogen, water is reduced. Hydrogen gas is produced. At the anode, the anion with the higher oxidation potential is discharged. If the anion is a halide, it is discharged. If the anion is not a halide, water is oxidized. Oxygen gas is produced. For example, electrolysis of aqueous sodium chloride produces hydrogen at the cathode and chlorine at the anode. Sodium hydroxide is also formed in the solution. This is the chlor-alkali process. Electrolysis of aqueous copper sulfate produces copper at the cathode and oxygen at the anode. Copper is deposited on the cathode. This is used in electroplating and purification of copper. Now let me explain Faraday's laws of electrolysis in detail. Faraday's first law states that the mass of a substance deposited or liberated at an electrode is directly proportional to the quantity of electricity passed. The quantity of electricity is measured in coulombs. 1 coulomb is 1 ampere second. The mass deposited is also proportional to the equivalent weight of the substance. The equivalent weight is the molar mass divided by the number of electrons transferred. Faraday's second law states that when the same quantity of electricity is passed through different electrolytes, the masses of substances deposited are proportional to their equivalent weights. These laws allow calculations of the amount of product formed. The formula is mass equals current times time times equivalent weight divided by Faraday's constant. Faraday's constant is 96500 coulombs per mole. It is the charge of 1 mole of electrons. For example, if a current of 2 amperes is passed through copper sulfate solution for 30 minutes, the mass of copper deposited can be calculated. First, calculate the charge. 2 amperes times 30 minutes times 60 seconds equals 3,600 coulombs. Then use the formula. Mass equals charge times equivalent weight divided by Faraday's constant. The equivalent weight of copper is 63.5 divided by 2, which is 31.75 grams per mole. The mass is 3,600 times 31.75 divided by 96500. This equals 1.18 grams. Faraday's laws are important for industrial electrolysis. Now let me explain the factors affecting electrolysis. Several factors affect the products of electrolysis. The nature of the electrolyte is important. The ions present determine which reactions occur. The concentration of the electrolyte affects the products. In dilute solutions, water may be electrolyzed instead of the ions. In concentrated solutions, the ions may be electrolyzed. The nature of the electrodes is also important. Inert electrodes like platinum or graphite do not react. Active electrodes like copper or silver can dissolve. The voltage applied affects the rate of electrolysis. Higher voltage increases the rate. The current also affects the rate. Higher current increases the rate. The temperature affects the conductivity of the electrolyte. Higher temperature increases conductivity. These factors must be considered in industrial electrolysis. Now let me explain the electrochemical series. The electrochemical series is a list of elements arranged in order of their standard electrode potentials. It shows the relative tendency of elements to gain or lose electrons. Elements at the top of the series are good reducing agents. They lose electrons easily. Elements at the bottom of the series are good oxidizing agents. They gain electrons easily. The electrochemical series can be used to predict the products of electrolysis. At the cathode, the ion with a higher reduction potential is discharged. At the anode, the ion with the higher oxidation potential is discharged. The electrochemical series is useful for understanding corrosion, electrochemistry, and metal extraction. Now, let me explain the applications of electrolysis. Electrolysis is used in many industries. It is used to extract metals from their ores. Aluminium is extracted from bauxite by electrolysis. Magnesium is extracted from magnesium chloride. Sodium is extracted from molten sodium chloride. Electrolysis is used to purify metals. Copper is purified by electrolysis. Gold and silver are purified by electrolysis. Electrolysis is used for electroplating. Silver plating, gold plating, and chrome plating are common. Electroplating is used to protect metals from corrosion and to improve appearance. Electrolysis is used to produce chemicals. Chlorine, sodium hydroxide, and hydrogen are produced by electrolysis. Electrolysis is used in batteries and fuel cells. Electrolysis is used in the production of aluminium foil and cans. Electrolysis is essential for modern industry. Now let me explain the difference between electrolytic cells and voltaic cells. A voltaic cell produces electricity from a chemical reaction. An electrolytic cell uses electricity to cause a chemical reaction. In a voltaic cell, the chemical reaction is spontaneous. In an electrolytic cell, the chemical reaction is non-spontaneous. In a voltaic cell, the anode is negative and the cathode is positive. In an electrolytic cell, the anode is positive and the cathode is negative. In a voltaic cell, oxidation occurs at the anode and reduction at the cathode. In an electrolytic cell, oxidation also occurs at the anode and reduction at the cathode. The difference is the direction of electron flow. In a voltaic cell, electrons flow from anode to cathode through the external circuit. In an electrolytic cell, electrons flow from the power supply to the cathode and from the anode back to the power supply. Both cells involve redox reactions. A common exam question asks you to explain the electrolysis of molten sodium chloride. Here is a sample answer. Molten sodium chloride contains Na+ and Cl ions. At the cathode, Na+ ions gain electrons to form sodium metal. At the anode, Cl ions lose electrons to form chlorine gas. The overall reaction is 2NaCl equals 2Na plus Cl2. Sodium metal is produced at the cathode. Chlorine gas is produced at the anode. This is the industrial method for producing sodium and chlorine. Another exam question asks you to apply Faraday's laws to calculate the mass of a product. Here is your answer. Faraday's first law states that the mass deposited is proportional to the charge passed. The charge is current times time. The mass is charge times equivalent weight divided by Faraday's constant. Faraday's constant is 96500 coulombs per mole. The equivalent weight is the molar mass divided by the number of electrons transferred. Use the formula to calculate the mass. Another exam question asks you to distinguish between electrolytic and voltaic cells. Here is your answer. A voltaic cell produces electricity from a chemical reaction. An electrolytic cell uses electricity to cause a chemical reaction. In a voltaic cell, the reaction is spontaneous. In an electrolytic cell, the reaction is non-spontaneous. In a voltaic cell, the anode is negative. In an electrolytic cell, the anode is positive. Both involve oxidation at the anode and reduction at the cathode. Let me give you a quick summary. Electrolysis is the decomposition of an electrolyte by an electric current. Electrolytes contain ions that move to the electrodes. At the cathode, reduction occurs. At the anode, oxidation occurs. Faraday's laws relate the mass deposited to the charge passed. The electrochemical series predicts the products of electrolysis. Electrolysis is used in metal extraction, purification, and electroplating. Electrolytic cells use electricity to drive non-spontaneous reactions. Practice these concepts. When you have them down, move to topic 3.